Hi, today we will talk about addition and subtraction identities. Sometimes we refer to sum and different identities then. Okay? Now, a lot of students, when they see psi of alpha plus beta, they feel that, oh, it should be psi of alpha plus psi of beta. Okay? They feel that, oh, can I just distribute the psi to alpha and beta? Okay? Now, actually, this is not the case, okay? Because we say that psi is operator, okay? Not just a number, okay? Not expressions. So therefore, when we work with the operator, then it's not working like this then. Okay? What is the proper way to work with the psi of alpha plus beta? It is psi of alpha cosine of beta plus cosine of alpha sine of beta. Okay? And then if we have sine of alpha minus beta, it will be sine of alpha cosine beta minus sine of alpha sine of beta then. Okay. Okay, so it actually, when you work with addition and subtraction, we have a particular formulas to work with sine, cosine, and tangent. Okay. And now what I would like to do is I would like to show you sine of alpha minus beta equal to sine of alpha cosine of beta plus sine of alpha sine of beta. Okay. And you could use this one and then to show you the rest of the identities then. Okay. Okay, so let us start now. Okay, so consider that now you have a unit circle. Okay. And then this angle right here is the angle beta. Okay. And you also have the angle alpha. Okay. So in this case, of course, you will see that this angle right here, it will be alpha minus beta then. Okay. And also, we just say that here, it will be alpha minus beta, this angle right here. Okay. Okay. Then, first of all, if this is the case, then now, let us look at this point right here. Okay. So remember back to chapter 5, we know that if I have the angle is beta right here, if this is a unit circle, that means this point right here, it will be cosine of beta and sine of beta then, right? Mhm. Then, similarly, if this angle right here is alpha, that means in this case right here, this point will be cosine of alpha, sine of alpha then. Okay. Okay. Now if you understand this, then now, of course, to this point, it will be cosine of alpha minus beta, and then sine of alpha minus beta then. Okay. Then now, let us look at what happened here now. Okay. So one thing about this is what we would like to do is I would like to find out this distance right here. Okay. Now you will see that the distance between this point and this point, it will the same distance between this point and this point. They are the same. The reason is they share the same angle, right? This angle right here is alpha minus beta. This also alpha minus beta. If we have a unit circle, okay, that means this distance d and this distance d must be the same. Okay. Then because of this idea right here, then if I want to use a distance formula, remember the distance formula basically is if I want to find the distance between 2 points, x1, y1, and x2, y2, then the distance will be a square root of x sub 2 minus x sub 1 to the square plus y sub 2 minus y sub 1 to the square then. Okay, so this is the distance formula that we have. Okay, so then first let us look at this distance d right here. Okay. This distance d is a distance between cosine alpha sine alpha and cosine beta sine beta then. Okay. Okay. And now if I plug it in, okay, maybe I name this one is d sub 1, this is d sub 2, okay? So we know the difference then. Then d sub 1, it will be square root of cosine alpha sine minus cosine beta to the square plus y2 sine alpha minus sine beta to the square then. Okay. Then now, what is d sub 2? Of course, to this one right here, we know that this point right here, it will be 1, 0. Okay. So then d sub 2 is equal to square root of cosine alpha minus beta minus 1 to the square plus sine alpha minus beta minus 0 to the square then. Okay. Then now, since d sub 1 and d sub 2, they are the same. So we know that in this case, d sub 1 equal to d sub 2. So meaning I will have a square root of cosine alpha minus cosine beta to the square plus psi alpha minus psi beta to the square is equal to, d sub 2 is cosine alpha minus beta minus 1 to the square plus psi alpha minus beta minus 0 to the square. Okay. Okay. Then now, of course, we know that if I have a minus b to the square, it is a squared minus 2ab plus b squared. Okay. So then let's see what is going on. Okay. Now then, first of all, what I would like to do is I would like to, since it is an equations, how about if I square both sides first? Then when I square both sides, that means I get rid of the square root. Okay. And I'm going to work with this one. This will be cosine alpha square minus 2 times cosine alpha cosine beta minus 2ab. And then we add cosine square beta then. Okay. And then we add same thing with this. So I will have psi square alpha minus 2 times psi alpha psi beta and then plus psi square beta then. Okay. It is equal to this side now. So to this one, I will have cosine square alpha minus beta minus 2 times cosine alpha minus beta times 1, right? And then plus 1. Okay. And we are going to add psi square alpha minus beta. Okay. Okay. And now we notice psi square alpha plus, I'm sorry, cosine square alpha plus psi square alpha is equal to 1. Cosine square beta plus psi square beta is also equal to 1. Okay. That means in this case right here, then we will have negative 2 cosine alpha cosine beta minus 2 times psi alpha psi beta and then v plus 2, right? Which is equal to, okay, this one is equal to 1 plus 1 is 2, negative 2 cosine alpha minus beta, and then we add 2. Okay. So now you will see that the left hand side we have plus 2, the right hand side we have plus 2. So if I move this over here, they cancel it. Then let's try this. I factor out the negative 2, so I will have cosine alpha cosine beta plus psi alpha psi beta, okay, is equal to negative 2 cosine alpha minus beta. Okay. And now, if I divide both sides by negative 2, okay, move this, then this cancel, right? This also cancel. So now, okay, I have cosine alpha minus beta is equal to cosine alpha cosine beta plus psi alpha psi beta. Okay. So then you will see that this is exactly what we have here then. Okay. Okay. Then of course I will not show you everything here because it takes a lot of time. But again, basically you could use this identity right here to help you to prove the rest of it then. Okay. Okay, so now again, if you want to know how to prove the rest of the identities, then you could email me or you could join my office hours, okay? And then we could talk about that too. Okay. Anyway, remember on the test, I will not test you how to prove the identities. That means how to prove the sum and the different identities, okay? Don't worry about this, okay? But I would like you to know how to use the identities to help you to work with the problems, okay? Okay, so then now let us start our first example. Right now, I have sine of 18 degree, cosine of 27 degree, plus cosine of 18 degree, sine of 27 degree. Okay. Then notice this angle and this angle same. Maybe I could consider that this is the angle alpha, and this angle and this angle is the same. Maybe I could consider that this is the angle beta. Okay. Then now I notice the right-hand side of sine of alpha plus beta has the form sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay. If I know that the right-hand side of the equations, then I will be able to work with the left-hand side. So meaning in this case right here, I will make it equal to sine of 18 degree plus 27 degree. Okay. So which is sine of 45 degree. And of course, we know that sine of 45 degree is root 2 over 2. Okay. Then we are done with this problem then. Okay. Then now, let's think about the second problem. This one is the one that I would like to solve the equations for all solutions. Okay. That means in this case, I would like to solve for x. This is what we want to do. Okay. Then to this equation right here, let us look at the left-hand side of the equation first. Okay. So to these equations, again, I found out that this angle and this angle the same. Maybe again, we could consider that this is the angle alpha. Okay. And this angle and this angle same. This will be the angle beta. Okay. Then now look at the form. I have cosine alpha cosine beta minus sine alpha sine beta. So in this case, it seemed that I could use these identities to help me to work with the problem then. Okay. Then, first of all, what I would like to do is I would like to get it from the right-hand side to the left-hand side. It means that I will have cosine of 5x plus 3x, which is equal to root 3 over 2. And now we will have cosine of x is equal to root 3 over 2. Then now, back to chapter 6, right? We learned how to solve these equations. Then I would like to let u equal to x. Then I have cosine of u equal to root 3 over 2. Okay. And remember ASTC. Okay. If cosine of u is a positive, in this case, u is in quadrant 1 and 4. That means I will have the solutions is in quadrant 1. And I also have the solutions in quadrant 4. Okay. Then what we need to do, properly, we could actually find out this reference angle u bar. Okay. So if I want to find the u bar, then I will have sine of u bar is equal to, remember we wrote with the absolute value, right? With 3 over 2. Okay. Then the u bar is the cosine inverse of with 3 over 2, which is equal to pi over 6 then. Mhm. And now, to the first u, which is in quadrant 1, then u is pi over 6 plus 2k pi. Okay. And if it is, the u is in quadrant 4, then I will have u is equal to pi 2 pi minus pi over 6 plus 2k pi. Okay. And of course, where k is an integer then. Then remember, we are not solving for u. We would like to solve for x, right? Then I will have x equal to pi over 6 plus 2k pi. X is equal to 11 pi over 6 plus 2k pi. Okay. What we need to do now, we would like to multiply both sides by 1 over 8. So I will have x is equal to pi over 48 plus 2k pi over 8. Okay. Same thing with this. Okay. So I have x is 11 pi over 6. 6 times 8 is 48 plus 2k pi over 8. Now we are going to simplify. Then I will have x is equal to pi over 48 plus k pi over 4, or x equal to 11 pi over 48 plus k pi over 4, where k is an integer. Okay, so this is my solution. Okay, and now let us look at the next example. Okay. To this example, I would like to rewrite in terms of sine and cosine. Okay. Now I have sine of x plus pi over 4 plus sine of x minus pi over 4. Okay. So in this case, then to the first one, I think that maybe let me clean this. I will use this one. Okay. And the second one, I will use this to help me to finish the problem. Okay. Then now let's see how we finish this problem then. So to this one, I will have this equal to cosine of x, cosine of pi over 4 minus sine of x, sine of pi over 4. Okay. Then we are going to add this one will be sine of x, cosine of pi over 4 minus cosine of x, sine of pi over 4 then. And now let us simplify this. Cosine of x with 2 over 2 minus sine of x with 2 over 2 plus sine of x with 2 over 2 minus cosine of x with 2 over 2. Then now you will see that this one and this one cancel. This one and this one cancel. So my answer is equal to 0 then. Okay. So right now, let's see how do we actually work with, okay, if I want to evaluate sine of 75 degree or tangent of negative pi over 12, how can we get exact value now? Okay. Okay, so before we get to this example right here, in order to get exact value, meaning I need to work with the special angles. Okay. So then let us go back to the table. Zero radian or 0 degree, pi over 6, 30 degree, pi over 4, 45 degree, pi over 2, pi over 3, 60 degree, and pi over 2 is 90 degree. Okay. Then now, if you remember this, then the table will give you sine of 0 equal to 0, sine of pi over 6 is 1/2, 2 over 2, or 3 over 2, and then 1. Okay, so if you remember this table right here, then it will help us to work on the problem then. Okay, so when you work with this type of problem, okay, the angle that we are working with is not randomly select. We need to work with the angle 30 degree, 45 degree, 60 degree, 90 degree, or maybe 0 degree. Okay, those are kind of like the angle that we need to work with. Okay, so again, we have a lot of choices to create the angle 75 degree. For example, we could write it as 20 degree plus 55 degree, right? Or maybe we could write it as 25 degree plus 50 degree, and so on and so forth. Okay. However, because we would like to work with again, we would like to find the exact value. So meaning in this case, those are not working then. Okay. What we need to do is we would like to use the special angles to help us to create, okay, to work with this angle 75 degree. Okay. So in this case, I only have one choices, right? So it will be 30 degree plus 45 degree then. Okay. So if you understand this, then we could work it out the problems. Okay. Again, I have sine of alpha plus beta. Then we have to use this sine of alpha cosine of beta plus cosine of alpha sine of beta then. So, which is sine of 30 degree cosine of 45 degree plus sine of 45 degree cosine of 30 degree then. Okay. Then now, sine of 30 degree is 1/2. Cosine of 45 is root 2 over 2. Sine of 45 degree is root 2 over 2. Cosine 30 degree is root 3 over 2. Okay. Then now, we are multiply them together. Then it will be root 2 over 4 plus root 6 over 4. Remember, root 2 cannot add to root 6 because they're not alike. So then my answer in this case, it will be root 2 plus root 6 divided by 4. Okay. And now, let us work with tangent of negative pi over 12 now. Okay. Now, to work it out this problem, okay, again, we know that the angle that we are using, okay, must be like pi over 6, pi over 4, and pi over 3, okay, something like this. Okay. And because we work with the 12, what I could do is I could multiply top and bottom by 2 for pi over 6. This multiply 3, and this multiply 4, right? So in this case, I will have 2 pi over 12, 3 pi over 12, and 4 pi over 12. Okay. Then now, in order to get to the negative pi over 12, what is the choices? Then I could work with pi over 6 minus pi over 4 then. Okay. The reason is 2 pi minus 3 pi give me negative pi divided by 12, which is what we have here. Okay. And now, to work with this problem, tangent of negative pi over 12, okay, I'm going to work with this tangent of alpha minus beta then, which is equal to tangent of pi over 6 minus tangent of pi over 4 divided by 1 plus tangent of pi over 6 times tangent of pi over 4. Okay. Mhm. Then of course we know that tangent of pi over 6 equal to root 3 over 3 minus tangent of pi over 4 is 1. 1 plus root 3 over 3 times 1, right? Then now, to solve this, we could multiply top and bottom by 3 because it is the LCD, right? Then I will have root 3 minus 3 divided by 3 plus root 3. And of course, we know we don't want square root of 3 in the denominator, okay? So then what we could do, we could multiply the conjugate pair. Okay? Meaning I multiply top and bottom by 3 minus root 3 then. Okay. And you have to remember that if I have a plus b times a minus b, it is equal to a squared minus b squared. Okay. Okay. So now 3 root 3 minus 3 minus 9 plus 3 root 3 all over the first term square minus the second term square. Okay. 3 root 3 plus 3 root 3, it is 6 root 3 minus 12, 3 plus negative 3 minus 9. And this one will be 9 minus 3. Then, of course, we could factor the 6. I have root 3 minus 2 divided by 6. So therefore, my answer, it will be root 3 minus 2 then. Then now look at number 5. Now to this problem, we have sine of A equal to 4 over 5, cosine of B equal to 1/3. And then with both A and B, they are in a quadrant 1. Okay. And then I would like to find out that what cosine of A plus B equal to. Then to this problem, what is my first step? I would like to take care of cosine of A plus B equal to cosine of A, cosine of B minus sine of A, sine of B then. Okay, so this is what we know. And now we know that sine of A is 4 over 5. Okay. And we know that cosine of B is 1/3. But we don't know what cosine of A equal to, and also sine of B equal to. That means now I would like to find out what they are, and let me plug it in. So if you remember how do we actually work out this problem, you might have sine of A is equal to 4 over 5. Okay. And A is in quadrant 1 because it's between 0 and power 2. Then I could draw triangles. Okay. Remember to indicate that angle here is A. And I'm going to paste the opposite of A is 4. The hypotenuse is 5. Okay. Then what I need to do is I just need to find out this side right here. And of course, we will find out that x squared plus 4 squared is equal to 5 squared. Okay. So we find out x equal to 3. So if x equal to 3, then cosine of A will be adjacent 3 divided by hypotenuse 5. Okay. Okay, and then now, okay, it's your turn. Go ahead and try to see if you could find sine of B now. Okay, so the information that I have is sine of cosine of B is equal to 1/3. Again, the reason is we work with cosine of B because we have the angle B, right? We work with the angle B. Okay. Then again, is in the first quadrant. This will be the angle B that I have here. Then cosine of B equal to 1/3. Adjacent is 1. Hypotenuse is 3. Okay. Then what I need to do is I need to find out what y is. So I have 1 square plus y square equal to 3 square. Okay. And which is equal to 2 but 2 with 2 then. Okay. Then now, of course, my sine of B, it will be 2 with 2 divided by 3. Okay. Then now, let's just simplify. 3 over 15 minus 8 with 2 over 15. My answer will be 3 minus 8 root 2 divided by 15. Now, let us work on the next page, which is we would like to prove the identities now. Okay. Now, remember proving identities. We always either start with the left-hand side and then prove it to the right-hand side. Or we start with the right-hand side and then we want to prove it to see if it is the same as the left-hand side, right? So this is the idea about proving. So in this case, what I would like to do with this problem, I would like to start with the left-hand side. Then now, based on what we know about the sum identity of a tangent, then it will be tangent of x plus tangent of pi over 4 over 1 minus tangent x tangent pi over 4. Okay. Then n plus 1 divided by 1 minus tangent of x. Okay, oh, that's it. This one's that then. Then how about this number 7? Okay. So to this one, I would like to start with the left-hand side. Okay. Then cosine of x plus y is cosine of x cosine of y minus sine of x sine of y. And we would like to multiply to cosine of x cosine of y plus sine of x sine of y. Okay. And now you notice that this one right here, it seems that these two expressions, they're the same. This one and this one the same. It's just like the conjugate pair that I have. A minus B. This is A, this is B. Times A plus B, which is equal to A squared minus B squared then. Okay. And now, meaning I will have the first term square and minus the second term square. Hmm. And now we will have cosine square x cosine square y minus sine square x sine square y. Okay, so this is what we have. And then now, let us look back to the problem. Do you see that to the problem we have, the solution that we have is cosine square x minus sine square y. It seems that maybe I would like to keep cosine square x and sine square y. Okay. That means it's telling me that maybe I need to find something to work with this one and this one then. Okay. Then now, remember sine square theta plus cosine square theta is equal to 1. Okay. So then in this case, cosine square y must be equal to 1 minus sine square y then. Okay. Okay. Cosine square x multiplied to 1 minus sine square y. Okay. And minus. We would like to keep sine square y So I'm going to modify this. So it will be 1 minus cosine square x sine square y. Okay. Then now I would like to distribute. So I will have cosine square x minus cosine square x sine square y. Okay, same thing here. I'm going to distribute this one to this, so I have negative sine square y minus sine square y cosine square x. Okay. Cosine square x minus cosine square x sine square y minus sine square y plus sine square y cosine square x. Okay. This one and this one, they cancel. And I have left cosine square x minus sine square y, which is equal to the right hand side. Okay. So I'm done. Okay, so then now in these lectures, okay, we introduce the addition and subtraction identities. Okay, thank you.